Hello friends. So in our last time class, we have seen the introductory part of the course, and as you may remember, we have covered what are electrical machines and we defined it, and we have also seen the applications of electrical machines. When we say electrical machine, we do mean that basically uh, electrical motors and the generators. That is the point what you have seen in our last time class. So we have also seen the classification of electrical machines. As you may remember, we classified electrical machines into main category. We said the static and the dynamic. And the static one example, we mentioned the transformer. Since there is no rotating part on that machine, we say it is an static electrical machines, and we have said that the dynamic type of electrical machines are motors and generators. Those are points what we have discussed in our last time class. So today we'll continue on the construction of DC machines. So we said last time there is no major physical difference between electric motors and the generators. So when we say DC machine, the construction aspect, we mean that the construction of DC motor and generator basically. So the physically assembled DC motor or generator, it may looks like this. Of course, the size based on the rating of the machine. And when we disassemble, we'll get the major components of the DC machines. And this is a cross-sectional view of the DC machines. Of course, here it is a detailed cross-sectional view. In each and every DC machines, we may not get all these components, basically like the compensating windings. Other component may not present. It depends on the size or the rating of the machines. So when we see the detail for the construction of the DC machine, basically, physically, the structure of DC machines has two main parts: the stationary part and the rotating part. As the name indicates, this stationary part, it's not a moving part of the DC machine, and it is stationary, and this contains especially, or we call this stationary part, we call it the stator or the field winding. The field winding. So the main purpose or the main design of this stationary part is to produce a magnetic flux. See on the diagram, the cross-sectional view of the diagram, see the internal one is the other part of the machine. Normally what I'm going to see, I'll tell you later on. So the outer part we call the stator yoke. The stator yoke. And this part we call the pole, it is connected to this, and the other windings are there. So this outer part of the machine, including the pointers which is fixed to it, we call it the stationary part of the machine. This stationary part of the machine contains the frame. Here's the frame, the outer part, and the main pole. Here are the main poles, north and south pole. It may be 2, 4, and above that based on the rating of the machine. And we call this is the main pole, and it has windings also, what you call the field winding. The field windings may be the series or they may be shunt. Here are field windings on the main pole, and we do have commutating pole for the bigger size of the machine. We have a commutating pole, and it has a winding also, the commutating field winding. So a machine part which is not moving and containing the main pole or the frame, the main pole and with their winding, we call it the stationary part of DC machine. And the second part is the rotating part or the movable part of the machine. It is called the rotor or the armature. So this is called the armature, and when you see the cross-sectional view, it is the internal part of the machine here, and physically it looks like this. It is a place where this rotating part is. This rotating part is the place where electrical energy is converted to mechanical energy, or mechanical energy is converted to electrical energy based on the machine type, based on the machine size. So this consists of the slots, armature slot. What we mean, it is a place where we're going to place the winding of the armature, and it has a windings here. These are the slots. Seems like they are slot, and these are the winding, and it has a commutator also. It is the mechanism that converts the internally generated signal into the DC commutator. We mentioned this in our last time class, and it has a commutator, and there is a shaft also. There is a shaft. This one, it is a shaft. So it consists of all these components. So electrical machines have two main parts: the stationary part and the rotating parts. And let us see in detail one by one. What is frame or yoke? It is a stationary part of the DC machine to which the main pole and the commutating poles are fixed. Here is the stationary part of our machine, the cylindrical one. So it has a slot where we produce the poles, and it has the windings, what we call it the field winding, and it has an external moving part called a frame. So this frame or yoke, it provides physical support for other parts. It is the main purpose of this frame is to provide their physical support. Support for the poles, support for the windings. And this frame, it is basically made from cast steel or rolled steel type, and it acts as outer protective cover for the machine. This is the outer pan which is exposed, and it acts as a protective cover from the environment, and it gives physical strength for the internal machine parts also. And it provides mechanical support for the pole. Here are the poles, and the poles are fixed on the yoke, so it is providing the mechanical support. And the main purpose, it carries a flux produced by the pole, and here a winding is there. As you know, the purpose of the winding is to carry the current, and when the current is produced inside this winding, flux is produced. So this flux is going to be carried out or managed by this yoke or frame, so that all the fluxes are guided into the armature or the rotor section. That is the main purpose of the frame. And the other part of the stationary part is pole and pole shoes. So see this, it is this part we call is a pole shoe, and the whole structure it is called the pole. When you come to the physically, see this part, we mean this part, it is called pole shoe, and there is a winding around the poles. So the purpose or the main function of the pole is just to hold the windings. So the field windings are going to be placed or wound around this pole. They are the one which is producing the pole, the windings, I mean. So the field windings are wound on the pole core. We call this the core of the winding, the machine, and supported by the pole shoe. So this is a pole shoe or pole face normally. It's called pole shoe. And this pole core, it is made up of sheet steel stacked and riveted together, and they form pole cores. This is a core, and it is made up of silicon. Why it is silicon? Just to reduce the hysteresis losses produced inside the machine, that has to be reduced. So any material cannot use for the core. We specifically use silicon type, and it's also laminated. When the core is produced, sheet of steels are going to be stacked together and laminated from one another to minimize the eddy current. Heat is there inside. When current is flowing inside, obviously it produces a heat, so that heat is a loss. To reduce that loss, we usually laminate the cores one from the other, and the pole cores are then bolted to the yoke by using this bolt, if you see there. And these pole cores are connected to the frame by using bolt, so that it will get straight. And the main purpose or the main service of the pole shoe, this pole shoe or face, is one, it gives support for the field winding, because these field windings are going to be placed around it. And second, it spreads the flux produced inside the air gap. Once flux is produced by the help of this field winding, and this pole shoe is going to be spread the flux produced into the rotor. That is the main purpose of the pole shoe. And the other part of the DC machines is the commutating pole. This feature is basically exists on the type of DC machine having larger capacities. So as you see, it is introduced in between the main pole, and the main purpose of the commutating pole is just to make sure that the sparkless operation of the DC machine. We'll come to it later on. One of the problems in a DC machine is armature reaction, and there are mechanisms to produce those armature reactions, and from those mechanisms, introducing a pole, what we call a commutating pole, is one mechanism. So the commutating poles are supplied with a DC machine, and their intention is to supply additional flux which are reduced by the armature reaction. So they are more or less produced with the same procedures with the core poles. So this part of the DC machine, we call it a commutating pole. It has a pole core, at the same time it has windings, similar with the main poles. But the only thing is they are introduced in between the main pole. They are introduced in between the main pole to reduce the armature effect. And the other component of the DC machines are windings. As you have seen it on the cross-sectional view, a number of windings are there basically. Here we have windings around the armature or the rotor, rotating part, we call it this armature winding, and we have windings around the main poles, we call it the field windings. We call it the field windings. And two principal winding on the DC machines are the armature winding. Here is the armature, so these are the winding across. So the two main principal windings on the DC machines are the armature winding and the field winding. And the armature windings are windings in which the voltage is induced, and the field windings are the windings where the main flux is produced. Obviously, as we have seen on the introductory, on the construction part, the field windings are existing on the main pole. field winding. It exists on the main pole and its main purpose is to produce the main flux. And the armature winding exists on the rotating part on the rotor or the armature of the DC machine, and its purpose is to induce the voltage or the current inside the machines. So in a normal DC machine, the armature windings are placed on the rotary part and the field windings are placed on the main pole. Here you might have recognized another windings either on the main pole, what we call them compensating winding. This is an additional winding which is placed on the main pole to reduce the armature effect. We call it a compensating winding. We'll come to it later on in detail. What is the purpose of these windings normally? So basically, armature winding and the field windings are a kind of winding which you may get in each and every DC machines. And the compensating winding and the compensating poles are introduced an additional to reduce the effect of armature on the DC machines. And here is the detail about the field windings. They are made of copper wire, obviously, and they are introduced. These field coils are formed wound to correct dimension and then put into the cover of the core, inside the core of the armature. They are going to be inserted, and when energized with the DC, they produces the main flux inside the air gap. These are the main winding. For example, this machine has got two pair of poles, north and south, two pair of poles, so winding is there across, and when current is flowing inside this coil, they produce the main field inside the machine or across the rotor of our DC machines. So all coils are connected in series so that the current will flow continuously inside the machine, and will produce the electrically or artificial pole, what we call it north and the south pole, will be produced inside the machine. And when you come to the armature or the rotating part of our DC machine, it has a winding, as you see. It's an armature winding, and it has a core also. It has a core. These are the core, and it has a slot, place where we'll place the our winding. So armature core or winding, they are laminated similar with the core of the stator. They are laminated, and they are made of steel, is core like we said, and the winding is made of the copper, similar with the winding on the field, but the cross-sectional area may be different normally. And slots, they are used to provide the place for the winding to be placed. This is the second main part of our DC machine. And the last one may not be the least, shaft. So the steel, what you are seeing passing through the core, we call it is a shaft. This is a shaft. The shaft has bearing. The bearing can be connected on the shaft, and the main purpose of the shaft on the DC motor is to provide mechanical strength to the armature and the conductor. See, the armature is constructed on the shaft. Core is there, windings are there, so their purpose is to give mechanical strength for this component. And it is rotor assembly is free to rotate by two bearings fixed between shaft and two covers. These are the bearing, and on the other side covers are there. So they are assembled. The shaft is assembled with the bearing, the core, and the wing. They are fixed to it. And their main purpose of the shaft on DC motor is to transfer mechanical energy to and from the machine. So when it is a motor, when it is a motor, the mechanical energy is going to be transferred to the load side by using this shaft. If it is a motor, I mean, if it is a generator, so the external mechanical force is applied through the shaft. So the main purpose of the shaft is one, to provide mechanical strength, second, to transfer energy to and from the machine. That is the main purpose of the shaft. And the other part of our DC machine is the commutator. We have seen the commutator on our introductory part. This is a component which converts internally generated AC into DC signal. So the main function of commutator in our DC motor, in our DC machine, for example, in a DC generator, it collects the current generated inside the machine, generator, as you know. Mechanical energy is converted into electrical energy, and that electrical energy produced inside the machine is collected and given to the load through this commutator. So its purpose to collect the generated current. And when you come to the motor, the commutator function is to provide current to the armature conductor. The induced signal is coming from, obviously, from the supply. So that supply is impressed into the armature through the commutator. So the commutator in DC machine is typically made of a copper bar. This is a commutator, and this is also the commutator, and the external wall is the brush. It is the brush. So the number of the commutator here, it is equivalent to the number of armature slot or coil on the machine. Their number is equal. This commutator number should be equal to the armature coil. It should be equal to the armature coil. And the last one, brush. This is the commutator we said, and this one is the brush. And this brush is a special type of material made of graphite or carbon, and it is held by the brush holder is there. It is held by that. And what makes it special, this material, it has to fulfill this property. One, good electrical conductivity has to be there. Second, less coefficient of friction is there, because this is a rotating part. Is going to be it has a contact with the brush, so it has to have low coefficient of friction, unless it will create a fire here. And the purpose for the brush is just to collect the signal which reach to the segment. I mean, the commutator segment has to be collected through the brush. It has to be collected through the brush, and that is the main function of the brush.